Welcome back to Plane Time, a Florida Aviation Network broadcasting live and in the clear from Orlando, Florida. Our guests today have been and will continue to be representatives of Porter Radials, Mr. Richard Porter and Mr. Michael Jannine, who are our guests today. They're back with us again. We're learning a lot about radial engines, in particular the Pratt & Whitney R985 engine. I'm not sure if it's possible to retrofit that to my Bonanza or not, Richard. Probably not, huh?
Might take be a lot nose heavy.
Yeah, be a little nose heavy and take a lot of sheet metal work. So I'll just continue with the Continental for right now, but it's fascinating to learn about the radial engines. So let's see, if I had an aircraft that had a radial engine, could I just pop in at Leeward Air Ranch and have you work on it right then, or do you have a backlog of work?
We've got the next year spoken for.
Wow.
We're not high volume, we're high quality, so we're only trying to do about 12 engines a year.
12 engines a year?
Yeah, and we're completely booked up for the next year right now. We don't do the R&Rs on customer-owned airplanes right there. That's probably one of the only downsides that I have about living in the Air Ranch. The Leeward family, when they set up the Air Ranch, they don't want people bringing in outside airplanes.
I see.
They're concerned about liability and stuff. I am doing my own airplane, which is in the hangar, but other than that, most of the airplanes, all the engines were shipped into us anyway.
So the owner disassembles the engine and ships it to you for repair or overhaul?
They pull it, strip all the airframe related stuff off of it, all the baffling, all that kind of stuff, and ship in what they want to have overhauled.
Okay, that makes sense. That makes sense.
Yeah, and it's a lot cheaper than flying the airplane down anyway.
Well, I'm sure it is.
They come from all over the place.
Yeah.
So.
Okay, so let's see. So you disassemble them, and you said down to the last bushing to have them totally disassembled, and then you inspect them and repair them and put them all back together. So as you have them all disassembled, I imagine there's an occasion where you find some really unique things that are wrong with them, even though the engine may have been running good up until that point.
Yeah, we have had that. We've found a few interesting things.
And so, Michael, I see you've got a whole tub full of parts there.
Yes, we have.
Are these brand new pieces, or are these things that you've taken out?
These
of
are
the
souvenirs.
Souvenirs, okay.
Souvenirs.
Not something that you'd put back in an engine?
No, no, no. These are man cave items or coffee table discussion.
I'll bet
pieces.
you've got some interesting stories behind some of these parts. Why don't you take it away and lead us through some of those?
This is a master rod bearing that has had some issues. This has started to spin and destroy itself, as you can see by the multicolored display out here. The master rod is mostly made of silver and lead and copper. And as you can see, all three elements are exposed right there, along with all the broken tangs through here and here. This is supposed to slide into a slot on the master rod and stay in position. However, this particular item did not. And it's called a spun bearing.
And just to clarify, the master rod is connected to the rods that go to each of the individual pistons? Is that correct?
The master rod goes to the number 5 cylinder, and they have articulating rods that go around the circumference of the master rod.
Okay, so the master rod connects to the number 5 cylinder.
Correct.
Piston, rather.
Piston.
Okay, and then articulating rods
Connect to the other 8.
Okay, good, good. I remember seeing pictures of the internal parts of a radial engine before, but I'd forgotten about the master rod going to cylinder number 5.
Yes,
So
we also
that
have
one, you didn't realize that there was anything wrong until you tore it apart? The aircraft owner didn't say there was a problem with it before?
No.
No, we actually, when we pulled cylinders off and found the pieces from the bearing laying down in the bottom of the engine, we started getting suspicious.
Yeah, that would be the big tip-off, right?
As time went on, we found the rest of it.
So the engines are supercharged, and that means we have an impeller compressing the air and pushing it to the cylinders.
Correct. And this next souvenir is an impeller that has met with some foreign object. Unsure exactly what it was, but this is, once again, the engine was running fine.
So this is on the front side of the blades there?
This is the front side of the impeller
Yeah.
coming directly from the
Point
inlet.
out the area where the damage is, just to make sure we understand. Yeah, right there.
Right up there.
Yeah, you can
all
definitely
the-
see that that's damaged.
That has chewed about 1/4 of an inch of material off of it,
1/4 inch of material.
just about.
So a piece of metal that tore that off, or
Something pretty
ice,
tough.
or-
Something
yeah.
had to went up through it, yeah.
Yeah. And Michael, you told me earlier that you can even get impeller damage from carburetor ice.
If there's enough of it.
Yeah. So it goes through the impeller because
This is directly on the other side of the carburetor inlet.
Okay. All right. Wow, that's pretty significant damage. So had that not been discovered and continued on, what would have just tore it completely and the impeller be
It should have
stopped?
it should have had a lot of vibration with damage this severe.
Now, did you say this was on a twin engine aircraft?
That was off of a Twin Beach, and they both had the same manifold pressure and the same amount of boost on takeoff.
But on one engine, this was the impeller, and the other engine, the
The
impeller was
other-
okay.
It was still fine, but they still both ran the same.
Wow, that's
The
amazing.
owner had no clue.
So this is an instance then where an owner can be unaware that there is something bad going on inside the engine, something that could eventually cause an emergency and
Could very well.
off-airport landing and the like. Yeah.
Yeah.
Wow. So it's good to keep an eye out and a vibration sensing out. If there's any vibration problems or sensing of that, that would be an
Yeah.
indicator. What's another indicator you said? Oil consumption. Sometimes that will be in.
Yeah, oil consumption has a lot to do with it also. That's what, Pratt & Whitney tells you to look out for. If you have excessive oil consumption, the next thing will come with spark plug fouling.
Oh, of
So
course.
obviously, if you don't get a good mag check,
Yeah.
or the thing starts loading up to where it's going to quit running in the air.
So that would be an indication of oil getting past the rings.
Going
and
past the
following the
rings, or it
plugs.
can also come out through the past the impeller in the bearings section
Okay.
of the blower section. It can actually leak through the blower case.
Okay.
That's another common area that
Yeah.
they'll fail in.
What, Richard? What is the difference between excessive oil consumption and normal oil consumption on a radial engine?
Everybody has their idea what normal would be. The book allows for up to like 1.5 gallons per hour.
A gallon and a half oil's consumed per hour
hour.
of engine operation.
Yeah, but that's over 9 cylinders also.
Yeah.
But that's a lot.
That's a lot.
And
yeah.
at today's dollars with the price of a gallon of oil, that's an awful lot.
Yeah.
So, we try to get them a lot drier than that. One of the last ones that we put out that was taken on a long cross country was on an aerobatic walker that's got the injection on it. And after 50 hours, he's got it down to where he's using about 1/4 an hour.
Quart an hour for the engine.
Yeah.
Okay. And if it were your engine in your airplane, once you get up and running, what would you consider tolerable for Richard? For oil
About the
consumption?
same.
One
1
quart. Per
And it's
hour.
hard to measure because the byproduct of a radial engine is they're going to seep some oil out of them. They're going to naturally run oil out through the valve guide clearances.
During operation.
During operation, they have to.
Okay. And then when they're
As
sitting on the
well
ground.
as sitting
what
on the
about-
ground, they do the same thing.
Right. That's why when you see
They don't leak oil, they mark their territory. That's a real good bumper sticker that was out for a long time.
It is. That's good. So oftentimes when you see an aircraft parked on the ramp that has a radial engine on it, you'll see some tubes and some buckets underneath. So that's to catch the oil that
That's
is-
an attempt, yeah.
Normally it
That's
leaks
an
out.
attempt. That's part of what they call a clean kit that they put on them where they drain back the rocker covers
Uh-huh.
and try to get rid of the oil that's run down into it.
and then pour it back into the engine when they're ready to go
Yeah,
and start it up
they'll
again.
collect about 2 gallons of oil during the time that it's sitting
Okay,
and
good.
pour it back into the case.
So does oil ever get past the rings and into the cylinder on top of the piston?
That's what we refer to as a hydraulic lock.
Is that bad?
That could be very bad.
Yeah.
That can be very detrimental. That's one of the most frequent failures that is brought on by operation,
Okay.
to the point that most all engine shops will not warranty a radial engine for that because of it,
Oh, okay.
because it's something that's totally out of our control.
How does that happen?
It's a natural thing. Oil is thin enough to run through the gaps of the rings.
Uh-huh.
Where the rings come together, they have a gap. and they're under it. The oil is in the top side of the piston through the crankcase. Oil can also run out of the oil tank down inside the engine,
Okay.
and it'll run down to the lower cylinders, and depends on also the exact position it's parked in, how the prop stopped, where it stopped at in relationship to valve timing.
Oh, of course. yeah.
Sometimes you'll get a intake valve, for example, it'll open up and the oil will run through that, run back into the intake pipe and collect enough oil that even though the engine turned over, as soon as you start it up, this cup full of oil comes up out of that pipe and blocks it.
Wow.
So
And
you
is,
get a real surprise then.
and is that a sample example of what you have there, Michael, with the piston? What happened with the hydraulic lock?
No, the connecting rod is,
Oh, the
this
connecting
connecting
rod,
rod
okay.
is short. It's, once again, when the measuring,
That's like a little bit of a lock, but not enough of a lock.
Okay.
But because of the thing being so near top center, it has enough pressure that it forced it over, and that actually has bent that rod.
So the big
It's
piece that
shrunk
we're,
it.
we're
It's
looking
actually
here.
condensed
this
it.
connecting rod is, it has been actually bent if you take a straight edge to it. I'm not sure that's
You
going to
can
be
actually,
visible.
you can actually see if you look over there at the part that the red tag is on, the high spot at the very end of that. You see a little bit of like an
Yeah.
upswept effect.
Yeah.
That is actually starting to bulge. And the center beam is, if you put a straight edge from that side to the other side, it's got about a 6/1000th rise on both sides of it right now.
6/1000th rise. And so this is a connecting rod going to one of the pistons.
This is the
That's an
articulating rod.
articulating rod. That connects to the
Articulating rod.
master rod.
Okay.
What they call the knuckle pin is a small diameter. The piston pin goes through the large diameter.
And so what happened here, it experienced greater than normal pressure in the cylinder and actually
Exactly.
compressed this rod.
Yeah, and
Because
then
of
the
the
next
extra
stage would be for it to fail and bend
Okay.
or break.
Okay.
They can do various things. They go different modes of failure.
So in your disassembly and overhaul, you take this out. Did you eyeball this and see the problem, or did you have to
We
put a
have
straight
precision. We have precision straight edges that have to lay
Okay.
across.
So you have all the equipment, obviously, to check to make sure that
That's
this
one
rod
of
is
one
good.
of many.
Yeah, one of many, I'm sure. Yeah, that's great. That's
Yeah.
great. So this is an example of what can happen with a hydraulic, what did you call it, a hydraulic
What they refer to as hydraulic locking.
locking.
Yeah.
Oil on the wrong side of the piston.
Oil will not compress. Air does. Oil doesn't.
Exactly. Okay.
So it gets full, and the piston cannot come on up, and it takes it out on the rod.
Okay. Wow. Sure looks like it did a bad number on that one. Well, Michael, what do we have here? It doesn't look like the best of pistons. Tell us about this one, please.
This is another coffee table souvenir, and this is where the upper piston, I believe, the upper ring separated and tried to come up through the top of the cylinder.
Oh, I can see the space where that top ring should be.
Yeah,
It's
it
gone.
actually broke the ring, and it fluttered back and forth so much that it eroded out the aluminum of the
The
piston
top part of the piston.
and totally ate it out
Yeah.
and left, went out through the top of the cylinder.
Yeah. Michael, if you would point to the slot where the ring should be, or that, yeah, right
in
where
there.
his finger is.
Right there.
And then just to the right of that is where the
It's a
ring,
big hole.
Yeah.
I'll stick my whole finger in it.
Yeah.
This initially came in for a set of cylinders that were coming off to be topped, and it wasn't this cylinder that failed the compression test.
It wasn't.
It was not. It was a different cylinder on the engine that was actually
Yeah.
leaking through a valve, so they pulled all of them off, brought them up, and that's what we found.
Yeah. And Michael, if you would also point to the break in the number 2 ring there, just around right there. Yeah. So right there. So the rings obviously don't come all the way together and touch.
That's actually when they're in this piston or in
Yeah.
the cylinder, they come together.
When they're in the
When they're
cylinder.
in there, they're like
to
that.
within about 25, 30
Yeah.
thousandths of an inch.
But there is just a little gap there, and that's where oil can seep through to get to the
That's
top
how
side.
oil goes past the rings and
Exactly.
gets on the other side of it. They run through those gaps.
All right, good.
There's 3 compression rings on top, and then there's what they call a double oil control ring at the bottom. It's missing one of them right now,
Uh-huh.
but there's 2 of those rings, like the one above the piston.
Oh, okay, so I see you moving them now.
And they control the oil flow.
So this break in the rings You said when they're inside the cylinder, there's just a very, very small gap there.
Yeah, it's compensated for expansion. They have to be
Exactly.
in the spec on them.
So do those gaps ever line up with all three rings?
You hope that they don't, but they do rotate because those crosshatch marks you were talking about are at an angle, and sometimes the ring will actually rotate on
So
them.
those crosshatch marks actually cause the rings to rotate.
And they all will randomly rotate, and every once in a while you take one off and they'll be lined up with each other.
I'll be darned.
But if you put it together and ran it for a while, they would unline again.
Yes.
Because they're constantly rotating.
Yeah. So when you took this one,
What you don't want is one that was what we refer to as parked, because most likely that top ring got locked in with carbon to where it couldn't rotate. And that's what led to it breaking.
oh, okay.
And kept the piece in that one spot long enough for it to chew itself out and spit it out.
And the carbon would be a result of incomplete combustion on the
Just
top side of the cylinder?
byproduct of operation.
Yeah, okay. I'll be darned.
They all build
So
with some carbon
this
on it.
owner, this operator, did not even realize that he had a problem with the piston
Had no clue.
until the disassembly.
Yep.
Wow.
This was off of a Twin Beach, and it actually was the other side of the airplane. It was the one that had a good impeller on it,
Uh-huh.
and the one that had the bad impeller that we showed you earlier they were all
Oh, this is the
okay on
same
it.
aircraft?
Same aircraft. The owner had no idea he had a problem with either one of them.
Wow. So that owner brought it in for a normal tear down, overhaul, and tear down and overhaul?
Started out, he was going to top overhaul one engine, and
Okay.
when we found this, he brought it in to do both engines. That's where we
Wisely
found the
so,
other one.
I'm sure.
Yeah.
Yeah. Wow. Well, that's great. That's great. What a great learning experience I'm sure it was for that pilot, and probably for you too. I mean, I know you've seen a lot, but I'm sure you learn a lot.
You've never seen it all.
Yeah, I'm sure that's the
There's
case.
never a day that I don't learn something new.
Well, that's the same way with me with piloting. I always
And that's
learn
what I
something
love
new.
about this is there is no boredom in it. Everything you do is different.
Good. And Richard, you told me this was a retirement job?
Yeah, I got a few more years left. That's what I want to do.
Good for you. Well, I'm glad you're doing this for the community that has radial engines, because they obviously need some. There's not very many overhaul and repair shops for radial engines, are there?
I've been trying to get an exact number, and the FAA can't really tell me, and it's hard in their records.
If you were to guess?
But guessing, I think I'm the first guy to get one approved in over 20 years.
Wow. So if there's some
And
existing
there's
ones.
been several
that-
other ones that have gone out of business in the
Yeah.
last 20 years.
Now, by approved, you mean a certified repair
As
station?
a certified repair
Yeah,
station.
Yeah.
There are a few mechanics that are doing a few of these engines on the side with 337s, like I explained earlier. But mostly it's down to just a small handful of actual repair stations.
Yeah. Wow. Well, Michael, let's see. I think you got another pieces and parts there. That looks broken.
This is another conversation piece for the coffee table. This is a thin wall piston pin, and there is an AD out for to use the thicker walls. This is separated, but the parts all interlock, and they stayed in place.
So even though it shattered like that,
It was shattered like that in a running engine. Once again, the owner didn't know it. He was there when it came apart. Surprised to see it, but we had no idea.
yeah.
And
And we're looking at the large circular thing is the underside of a piston, right?
Correct.
Turn that
Yeah,
just a little
that's
bit
the
so
piston
that the
that came
audience
out
can
of-
see that, yes, it is a piston.
and
Okay.
you can see how the parts got in. It did some damage to it, chewed it
Yeah.
up a little bit.
Yeah, a
Now
lot.
that's what they refer to as a light piston pin, which is the original design. They've come up with a heavier one to reinforce it. because
Heavier
they
meaning
had
thicker
a
walls.
Thicker wall, a little heavier pin, they weigh more. We actually have to put an extra counterweight bolted onto the crankshaft to use them. They have to be replaced in sets.
So you can't just replace one part without compensating for it in another way.
It would affect your balance on this, so
Obviously,
it's
yeah.
rebalanced to compensate for
Yeah,
the heavier.
but you would replace all 9
I
of them,
won't
right?
run this lighter one. I'm not gonna take
Oh.
a chance of them breaking.
So if you disassemble an engine and you see the lighter ones on there, you'll replace them with the heavier
They
weight
get
ones.
replaced with a heavier. They
Yeah,
get
that makes
modified.
sense. Well, that's good.
And
That's
they're
good.
manufacturing the heavier ones new now. They're actually.
Oh, okay.
There are a handful of parts that we've actually run out of that are manufacturing from scratch again.
So have you had to manufacture parts yourself from scratch?
Not myself,
Okay.
but we have some excellent part support. There's a couple of companies in general that have done a great job of supporting them.
Uh-huh.
And they've got enough of the old stuff left over that as they run into the need, they will continue to have them made because it's in their best interest. If we can't find all the parts, we can't use the parts they have.
Right. So are these Pratt & Whitney producing these parts, or are these
No,
third-party?
Pratt & Whitney has orphaned this engine completely back in the 70s.
Oh, okay. Okay.
The last revision done on the maintenance manual was in 1978, I believe it was.
Something like that.
78 on the last one.
The maintenance
and
manual that you use for
The
overhauls?
overhaul manual and the current approved manual is done in 78. There have been no revisions since that time.
So does that mean there really isn't anything to revise, or they just have orphaned the engine and they just
They've
kinda,
orphaned it,
they don't want to have anything
but
to do
they
with it
also
anymore?
had enough, they've had pretty well had all their bulletins worked out and stuff. There has been very little come along since that time.
Well, it's been around a long time, since the
It's
20s, you
been
said.
well
that
proven,
design- Yeah,
yeah.
that's good. That's good. And still a good, viable engine, provided it's torn down and
I
overhauled
think
on a
they'll be
routine
around
basis.
a lot longer than we will.
That's good. That's
That's
good
one
to
of the
know.
concerns that I have, is that the people that own these, people that own old classic airplanes, we have to realize, and myself included, I've got the 49 Cessna 195 that has been modified to put a 985 on it. And that's my interest in wanting to overhaul 985s in the first
That's right. That's
place.
what started this whole business.
This whole thing was started when my own engine failed, and I was too hard-headed to go hire somebody to do it. I
Yeah.
decided, how hard could it be? So I decided
Yeah.
to tool up and do it. So we got it apart. Then I realized it takes a whole lot more to put it back together, and a whole lot more to machine it and fit everything. So it was interesting,
Yeah.
and it has been. It's been a real challenge, but it's labor of love type thing. But we got to realize we're the stewards of these things. We're not the owners; they own us.
Yeah.
And we have to give them what they take to take care of them and feed them and keep them going.
That's a
Because
great.
they're going to outlive us.
Yeah.
If maintained properly, flown properly, cared for, we need to pass them on to somebody. And that includes the work, that includes everything.
Yeah. Yeah.
And that's,
Well, that's great. I like the way you point that out, that we're the stewards of these engines. We don't own them; they own us, and they rely on us to keep them going well. So that's good. And in a few minutes, we're going to talk about what you're doing for the future. But I think Michael is over there with some additional parts that I don't know if there's anything wrong with this one or not. Is there something wrong there that you want to show us, Michael?
This is an impeller shaft, and the impeller.
can you get a view of the side where it has scuffed off on the spacer?
So this is the impeller that runs the
That's the final
supercharger.
wheel that goes through the impeller itself. And that's the one that turns 23,000
There
RPM.
it is.
Okay. Grab the impeller just once again and put it in the camera view so that we can know. So this shaft goes inside the, the
It sets on
impeller
there.
sits on the shaft.
Yes.
And there are 3 high-speed bearings that support that in a ball
Okay.
bearing fashion.
All right.
And one of the misconceptions that people have is they think that there's a seal in there or something. And when these things start using oil and stuff, they think the seal has went bad.
Oh,
And all of the internet mechanics that are out there that really don't know much about them or never been into one, all make that assumption. But it's not actually a seal, it's a spacer that sits on top of the bearings.
is that
And
what you have there, Michael?
It
the
goes
spacer?
through an aluminum plate,
Yes.
and it has a 1/1000th clearance around the diameter of that spacer. So the hole is 2/1000ths larger than this diameter is.
Wow.
And it's sitting there turning at 23,000. And if that bearing starts to fail, that spacer can get over against the aluminum and start rubbing.
Okay.
And then it picks up metal and it starts to enlarge the hole so that next thing you know, it's that clearance is no longer 2/1000ths, it could be like 20,000ths.
Okay. Wow.
And that's what happens with them.
That's pretty amazing. So that shaft then and the impeller are running at 23,000 RPM when the engine's operation, and 2/1000ths clearance between some of the parts, 2 1/1000ths of an inch. Very, very tight.
Yeah, that's how it keeps from throwing oil into the intake side of the thing,
Okay.
because you got to lubricate the bearings.
Right. But
And
not let oil pass
There's
through.
forced oil lubricated through a restricted tube.
Michael, I think we got time for one more part and piece if you have it, and then we're going to.
Yes, I do.
So he calls these his coffee table items. So you can just imagine the living room in Michael's house. If you go to sit down at the coffee table, there's no place to put a cup of coffee because he's got all these parts and pieces on it that are pleasant memories or maybe not so pleasant memories. But tell us about this one, Michael.
This is part of the counterweight bushing that goes in the crankshaft. This is the part that is used for balance. And there's two of these. This is one side. You can see the threads that go in there over the cap, and it fits into that. And this is supposed to slide into the bushing that Richard mentioned earlier. That gets is the
Free
AD
float.
is the AD that you have to disassemble a complete crankshaft for to comply with.
Oh, that's one of the last things that you take off. Or
That's
take
the
out.
next to the last thing.
Next
That
to the
comes
last
out, and then the bushing that rides in would be pressed out after that.
Okay.
And that separates, there's another half of it that goes inside that inner with a bolt holding it together.
And so what are we seeing on this one, Michael? That's
The
wrong?
scarring.
Scarring, okay.
Yeah, that's supposed to be smooth and polished, but see how it is all galded and raised?
Exactly.
And that's what they found. That's the reason why this AD note came out.
Once again, not something you can tell on a pre-flight inspection, but on an engine
You
teardown.
won't tell a thing about it.
That's for sure.
That's why it
for
runs
sure.
great.
Yeah, wow. Well, we've seen some really great examples here of parts and pieces that you wouldn't discuss or wouldn't realize that were bad shape until you disassemble the engine and the like. And so I can only imagine that owner-operators would benefit from this as well if they were there when their engine was torn down, whether it's a Radial or another engine, but particularly with the Radial engine and the like. So, Richard, you'd mentioned that there aren't very many other certified repair stations for Radial engines. You're one of the few and one of the probably the most recent one that's been certified to be a repair station and the like. So what can we do to improve this situation, get more mechanics involved in Radial engine repair and overhauls and the like? What can we do to make this a better situation, do you think?
Make COVID go away would help.
That would help us all,
Because
wouldn't it?
unfortunately, one of our plans has been to start inviting A&P students and people that are interested to come in. And we had to put that all on hold. When we were on your show last year, we were on, and the lady from the school in Lakeland was here, and we had talked about that. She said she would love to do something like that, but because of COVID, we couldn't even discuss it yet. And I think they're still shut down now with that in the schools. So
Yeah.
as soon as that opens up, we're going to try to start getting people to come up, and we got to find that limited percentage that really think this is neat. This is probably like the hot rod guys of the AMPs
Yeah.
that would have more of an interest in doing radials and getting. They're greasy, they're dirty, but they're really cool. And you know,
Yes, we're looking to set up an apprenticeship program for this, and then if we can get some enough students interested or enough young AMPs interested in not only in this apprenticeship program, but employment.
Yeah, well, it's great. It's a great profession to be in, and I would hope that we will have more interested people that will come see your operation, get interested in it, get excited about it, and the like, and opportunities for people in A&P schools to come visit you, perhaps an apprenticeship program and the like. All these things are wonderful. If there's an opportunity for someone to fund a scholarship for this, that would be another way of
that's
improving it.
ideas that we would like to explore. We're
Okay.
trying to do that because I think there are a lot of people out there that aviation has been good to, and I think they're looking for ways to pay it back.
Yeah, paying it forward. That's important for all of us, indeed. Indeed it is. So we've had a great session here with Plane Time this morning, learning all about Pratt & Whitney, our 985 radial engines and radial engines in general. I'm sorry you couldn't be with us today, Ben Coleman, but we wish you the best for a speedy recovery, and we'll look forward to Ben being back with us for Plane Time early next year when we restart these programs again. But for today, we're halfway through Plane Time. So thank you to Michael Jannine and Richard Porter for your great presentations on radial engines and the like. Stay tuned because in a few moments we'll have the weather guy, Dr. George Bertuska, who's going to give us some great background information and knowledge skills on weather analysis and the like, as well as how to build a weather instrument of your own. So stay tuned. We'll be back in just a few minutes with Dr. George Bertuska. I'm Ron Timmermans with the Florida Aviation Network. We're broadcasting live and in the clear from Orlando, Florida. Thanks for joining us. Stay tuned for the next session.